People think of HVAC as this invisible thing that is a huge problem when you don't have it. If it works, you don't think about it ever. And so there was this excitement at the time around electric cars, wildly fun to drive, absolutely the future. And there was no obvious connection to how this could be true in HVAC. And we quickly dispelled that myth. People really do care about their air conditioners. And I think the reason that it's not exciting is because the designers of these products have been wildly unimaginative. And once we identified that as like, we're going to make this exciting for people and we're going to solve the infrastructure deployment problem, that's what really came up with our business thesis. So this is how we're going to make a dent in the emissions problem.
Hi, folks. I'm Conor Gaughan, and welcome to Consensus in Conversation, a podcast where we're talking to the innovators, entrepreneurs, and thought leaders who are committed to building successful businesses that also help us build a better world. Hard to believe, but summer is just about here, and it feels like it was only a few days ago that I had to start an episode with hard to believe that spring is in the air. Alas, here we are. The days are getting longer, and the temperature's on the rise. I actually switched on my AC the other day for the first time this year, which reminded me of a horrible annual ritual from my finance days back in New York City, one I'm sure quite a few of you East Coast folks are all too familiar with. The annual putting in of the window units. Nothing says summer is here like lugging that heavy AC unit out of the closet, trying to balance it just right in the window so it doesn't plummet down 3 stories, and watching it triple your monthly electric bill, just to keep the apartment cool enough to not suffocate at night. Those were the good old days. I've actually been thinking a lot about HVAC lately, especially since our recent conversation with Monica Suri of Glacier Grid. If you missed that one, check it out. It's a really great talk on some impactful technology that's revolutionizing cold chain in the commercial cooling world. HVAC is a prime example of that concept of hidden economies that we've been talking about this season. Something that's totally essential to modern life, but that we take for granted in the day-to-day. And it's not just true for commercial cooling, it's equally or maybe doubly true for residential HVAC. We all benefit from the cold chain indirectly, but personal HVAC is something nearly all of us experience firsthand every day. If you want an object lesson in just how much we take it for granted, imagine spending a full year with no AC in the summer or no heat in the winter. And I'm very specifically saying imagine doing that because depending on where you live, actually doing that could potentially be fatal, which sort of proves the point of how important it is. Unfortunately, heating and cooling both come with a ton of negative externalities. Like we talked about in the episode with Monica, cooling technology is responsible for around 8% of global greenhouse gas emissions annually. Combine that with a whopping 10% from heating, you're talking about nearly 1/5 of all greenhouse gas emissions from heating and cooling. They both consume huge amounts of energy, and even when electrified, their demand curves are irregular because they depend on the weather, which drives the continued need for fast on, fast off peaker plants that are some of the heaviest consumers of fossil fuels. That energy consumption makes HVACs expensive, which can be a major strain on people in areas where the climate makes heating or cooling not exactly optional. And because a lot of companies have, not illogically, assumed that the demand curve for HVAC is pretty inelastic, there hasn't been a lot of innovation in the field, which is why every year us East Coasters are still hauling out those boxy old window AC units in the summer. Suffice to say, the HVAC field is not only a major untapped source of impact in terms of sustainability and probably profitability, but it's also been crying out for a little TLC on the design side too. So if someone was to, say, combine personal heating and cooling into one electrified system that's easy to install, energy efficient, reduces emissions by 95%, and looks like a beautiful piece of furniture for your home, they'd have a game-changing product on their hands, right? Well, that's exactly what my guest today has done. Vince Romanin is the co-founder and CEO of Gradient, a startup that is changing the HVAC game by building a better air source heat pump. Heat pumps are pretty incredible technology that are already playing a big role in the clean energy transition. But the fact that Vince and the Gradient team have gone that extra mile to not just make them useful, but also make them, if you pardon the pun, cool, that really got my attention, and I knew we had to get Vince on the show. He's a self-confessed, lifelong thermoengineering nerd. He got his MS and PhD in mechanical engineering and heat transfer from Berkeley before doing a stint as a development engineer at Otherlab, where he first came up with the concept for Gradient. As I said before on the show, I always loved the design-forward approach to problem-solving, and I was super excited to pick Vince's brain on bringing it to one of climate tech's most challenging fields. So, let's jump into the conversation. Thanks so much for joining today. So I want to start at the very beginning and hear just about your upbringing. So where are you from originally?
from a small town in Ohio called Grafton. It's about half an hour west of Cleveland. There's one stoplight and a great pizza shop and not much else.
And I mean, I think you're the second founder that comes to us from the world of thermal engineering, which is a very specific vocation. So I'm curious, like, even back then as a kid growing up in Ohio, was your future written on the wall? Were you always going to be an engineer?
I think it was, and I maybe didn't see it as much back then. I don't know, for lack of a better term, I love to like set things on fire, play with engines. And this turns into the world of thermodynamics, engineering, fluid mechanics, planes, cars, engines, and HVAC.
Do you remember like the first thing you built or, model you engineered? Like, does that moment kind of stick out in your memory?
It does. So my parents loved to ride four-wheelers and motorcycles. And also, I didn't have a ton of money as a high schooler. So like we would buy the cheapest secondhand four-wheeler and it would break all the time. And I spent more time fixing it. But I actually think it was model rockets that got me the most excited. I had an uncle who loved building model rockets. And we were all kids. He would come build them with us. We bought like the kits from the model stores. And one day he's like, all right, we're going to step it up. We're going to make our own engine casing. We're going to make our own rocket fuel and pack the engine. We like designed the whole thing. Super fun. It didn't work. It didn't get off the ground.
Your first lesson in entrepreneurship too, I bet.
Yeah. I was pretty young. I had no business playing with such dangerous chemicals that early. And my mom was very reluctant, but my uncle was a very experienced engineer. And so she let it happen. But, it was the first like, hey, you don't have to follow the instructions. You can do this yourself. You can kind of chart your own path. And he walked us through like the reason we were building everything. And it was a really, really fun process.
So when did this kind of intellectual curiosity as a kid turn into something that you were really committed to studying or kind of wanted to pursue?
I think I spent probably a couple minutes in high school thinking like, all right, what am I going to be? My whole family was engineers. So it was kind of the obvious choice. I considered a couple other fields and I just saw that there was a ton of opportunity in engineering. I remember asking my dad, hey, maybe I want to be a chef instead. Maybe I want to go to culinary school. And he was like, you're going to make less money and work really, really long nights and weekends. And I was like, great point. And then I went and started a company where I also work long nights and weekends.
Yeah. And the food's probably not as good, to be honest. The food's probably a lot worse.
Yeah. But anyway, I went to school to become an engineer. And I think a lot of my upbringing, I was far from rich or privileged, but, I felt like I should use my skills as an engineer to make the world a better place, right? That was always like kind of ingrained in my upbringing and in my undergrad school is a huge part of University of Dayton's ethos. And so it was always kind of like, all right, my career is going to be an engineer. What are the important problems? What are the big problems that we need to solve?
So, I mean, what was it about University of Dayton that attracted you there in the first place? It's a cool school.
Yeah, I really liked it there. Very formative experience, obviously. I think that I didn't cast as broad of a net for an undergrad school as maybe I should have. And I think that, a lot of my engineering role models were kind of folks that were staying local and working for larger companies. And so I visited a lot of schools. I was going to go to Purdue University, great engineering school. And I went to University of Dayton. They both gave me a much bigger scholarship. So money was a factor here. And also when I visited, I immediately fell in love with the campus and the community.
Yeah.
They had a really strong community feel and a very service-focused engineering program. And so it was kind of love at first sight as far as schools go. Like I really felt at home there right away. And so I ended up going there.
I want to get back to that in just a second. But I read that you spent some time in the GE EID program. I guess, first of all, what was it for folks that don't know? And then, curious like if that kind of helped give you visibility, or if you look back on that and think that it prepared you for a career in a way that maybe is unique and cool.
It definitely did. I mean, this was a rotating internship program. A lot of engineering schools call it a co-op. Only difference between a co-op and an internship is usually in the co-op you go back, right? So I did 5 semesters, which was a lot. Most students aren't doing 5 semesters with their internship, but I didn't want to graduate on time. I wanted to take 5 years and really figure out what I wanted to do. And the world of engineering that was more common in the Midwest is you work for a big company. You don't get the startup bug in Ohio as much as you do in California. And so GE was a great company. They were doing cool things. They had an amazing aerospace program that I was part of. And I tried many different rotations. I was super intentional. Every rotation, I would go and talk to other managers, other co-ops, and figure out where did I want to go next and why. And they also treated their co-ops really, really well. We weren't doing busy work. We were doing real engineering work, and it was a very educational experience. And I think the main thing I learned from that is like, I wasn't sufficiently inspired. I didn't think I had sufficient impact in those rotations. I was, for lack of a better word, a little bit bored. Not bored with the work, but like bored with the idea that this was going to be the focus of my career for the next 30 to 40 years. And it was at the same time I was talking to my advisor at Dayton, and he was like, you could go to grad school. You could get into any grad school you wanted. And there's a lot more interesting and creative things you can do, a lot more impactful things you could do in that path. And so the EID program, it did two things. One, it gave me a lot of great experience in the world of engineering. It gave me an extra year in undergrad to kind of think about what I wanted to do with my career. And it taught me that like, all right, maybe I don't want to be a GE lifer. Maybe I want to go out and do something where I might have a little bit more control.
Incredibly valuable, but often overlooked, I think, kind of lesson. So then you end up for grad school looking out west, the Bay Area, where we've talked to a lot of founders that come from Cal and Stanford, and it seems like there's an ethos there that's very directly linked to startups and entrepreneurship. So tell me about that trajectory. How did you handle that shift? And was that obviously, or maybe not obviously, was that intentional? How did that happen?
It was culture shock in a good way. I remember going out as an early grad student, talking to some of the undergrads in like some networking or mentorship program. And I was talking about like the co-op process to them. And I realized like, this is not standard here. No one's doing co-ops at Berkeley. Right. Everyone's trying to get internships at like the cool startups or tech companies. Very different world. But partially in reaction to me saying, okay, I don't want to be a big company lifer. I want to do something a little more dynamic and interesting. I was like, I really want to be in a place like the Bay Area where they are kind of leading the charge of both research and startups in the climate world. And similarly, the community didn't hurt. The Berkeley community was very welcoming. It didn't hurt that the weather was perfect. I'd spent a lot of my life in Ohio. It was time to see somewhere new. For visit day, they put us on the roof of the engineering building with a view of the bay and of the bridge. And they had a keg of beer. And I was sitting there drinking beer on a perfect day, looking over the view. And I was like, I think I could stay here for 5 years. And so that was definitely part of it too.
What was the focus of your research for your graduate program?
My graduate research was a small scale turbine for combined solar heat and power. And so the idea here is, this was back in 2008 was when I started. PV cells were still too expensive. We thought that they were going to stay that way. Spoiler alert, that thought ended up being wrong. PV got cheap way quicker, which kind of nudged my career in a certain direction, which I'm sure we'll get to. But at the time, PV cells were far too expensive to be a scalable clean energy solution. And so the thought was that if you built basically a power plant that turned the heat from the sun into electricity, you could also use the waste heat from that process to cover a different part of our energy sector, which is the hot water or the HVAC in our homes. And so we were looking at small scale turbines that could make that mini power plant super efficient.
You've hinted at this a couple of times. I think now's the perfect time to introduce it even more directly. So you've talked a lot in past interviews and hinted at today that you really wanted to get involved in something that was doing good. And I think we can draw a pretty direct link for most of your career, and certainly with what you're doing now at Gradient, to climate change as one of those big problems that you're using your superpowers to solve. Mm-hmm. But I'm curious what brought climate issues, like when that entered your awareness, when that became kind of the issue that you thought you want to be out there solving?
It was most likely my thesis advisor at Dayton in undergrad, Dr. Kevin Hallinan. He was very focused on climate issues, and it was a big part of their pedagogy there. And so that was probably where I first learned about it. I think that when I went to University of California, Berkeley, they had one of the leading research groups there. I think that my advisor was also a huge fan of it. So it's probably that early experience with my advisor in undergrad.
I mean, as you were working your way through graduate school, this kind of ethos in mind, did you have a sense for where your career was going to go as you finished your academic chapter?
I don't think I did. I think that I had a really problem-focused, and even today, a really problem-focused ethos, right? I was very focused on, I want to solve this problem and I'll do whatever it takes to solve it. And I think if I would have found an opportunity to solve it at a large company versus a small company, it wouldn't have mattered. If I had an opportunity to solve it as a researcher versus CEO, I don't think that mattered to me. I was just really interested in solving the problem, right? It almost became like a daily experience where like you see the infrastructure we built and the wonderful benefits to human productivity and health. and enjoyment that it makes. And you're like, but we're not cleaning up our mess with all this stuff. And it's possible. Like I could, as an engineer, as a thermodynamicist, it was obvious that there was a better way to do our world, our industry, and our infrastructure that didn't have this negative consequence. And once you see that, kind of becomes like an earworm and you can't help but want to fix it.
I think it's certainly a worldview that once you adopt it, it's really hard to imagine a different way of seeing things. So as you think about your career leading to where you are now, I think it's worth spending a little time talking about your time at otherlab. So how did you end up there? What was that role? What were you focused on? What were you doing?
Yeah, otherlab was a huge, huge step for me. After grad school, I went and worked for someone I knew in grad school for a research company, a large company. I think this sort of mirrors GE as like here is a big company doing the thing I want to do. And I was like, this is a little bit slow. This is a little bit bureaucratic. I would like to see things move faster and think bigger. And that's when I got a job at otherlab. Otherlab was the antithesis of corporate anything. It is this beautiful 100-year-old pipe organ factory in the Mission District in San Francisco. Everything is old wood. There's pieces of pipe organs everywhere. There's bikes hanging on the wall. There's robots everywhere. It is very like mad scientist playground. And it is a place also where there is a lot of incredibly smart people in different disciplines. And they encourage the like crazy ideas, the big thinking, the like, what if we could do this instead of this won't work because of whatever. It was also a community of people who have started companies before, some that were successful and some that weren't successful. And so you had access to a lot of people who'd been down that road. And that's where I really caught the bug, right? It was almost infectious there, where like the path was more obvious in front of me of how I could go from like a problem statement and an idea of what we could do better to scaling a company.
And you talk about that space as a place where there was real opportunities for aha moments and for your aha moment. I think it's a good segue to get to Gradient. So what were kind of a couple of the oh shit moments that reoriented you towards the current problem that you're working to solve on the HVAC side of the equation?
I think it was the realization that there was not the attention due to this sector of our carbon emissions that it deserved. We think about transportation and electricity generation as like the huge, chunky, major problems in emissions. Coal-fired power plants and cars are the visceral images in your head of how we're emitting. We did a lot of the math that showed, all right, all cars are now electric. All power plants are now electricity. You have this other chunk of emissions that we haven't addressed, which is the electrification of our buildings. Just like our cars, burn a lot of fossil fuels, huge percentage. Also, we realized then, okay, let's fix that. Let's snap our fingers and make all buildings electric. It's not done. And the reason for that is the refrigerants that we use today are almost as big of a problem as the fossil fuels we're burning in buildings. And nobody was addressing that either. And so this seemed super important. And then lastly, there's the grid scaling problem. How are you going to make our grid have the capacity to handle this massive jump in electricity? To do that, all of our buildings need to be smart. And so this kind of led to all right, 3 things need to be true of buildings in order for us to have a zero carbon infrastructure. Heat pumps with better refrigerants that are smart and talking to the grid. And in the world I was in of like government research conferences and other climate folks, it just seemed that like this major problem with huge benefits to be had for public health was not getting the attention that was commensurate with the size of its impact.
Right.
And so really started focusing on how we could do this, how we could make sure that we got heat pumps with better refrigerants that were smart.
So perfect segue to Gradient. Let's start with just the elevator pitch. What is Gradient? What do you make? What is it for? How are you unique?
So the climate side I covered. We know what needs to be true to solve the decarbonization problem, but that's not quite a business, right? And I think there's 2 major insights that happened. We got our first external source of funding, and the first thing we did is talk to as many customers. And it's funny, like this was another huge turning point. Engineering school does not prepare you to run a business. I was kind of at that point, like, I understand how the thermodynamics of these systems work, and I understand how to fix it. What am I going to learn from talking to a bunch of customers? But of course you do. You call as many customers as you can. Talk to everyone in every piece of the sector. And I think that's what led us to kind of the next phase of this, which is that there's 2 major problems that were blocking evolution of HVAC in buildings. One, the cost is on the deployment, not the hardware, right?
Yep.
It's not like electric cars, you've got to make the car cheaper, right? In HVAC, it is the install process that drives it. And so you have to think of how this technology that you build interacts with the built environment. And then two is you really have to think about how this interacts with people, right? People think of HVAC as this invisible thing. To borrow a phrase, like having HVAC isn't everything, but not having it is, right? It is it is a huge problem when you don't have it. If it works, you don't think about it ever.
Yeah.
And so there was this excitement at the time around electric cars, like your Tesla Roadster, your Model S was so fast and fun. It was absolutely the future. People were buying it because it was wildly fun to drive. And there was no obvious connection to how this could be true in HVAC because like who gives a shit about their air conditioner? And we quickly dispel that myth. People do care. People really do care about their air conditioners. And I think the reason that it's not exciting is because the designers of these products have been wildly unimaginative. And so the kind of unlock that there is a real emotional human problem that we can solve with this product. We can make this like something that's wildly exciting for customers was the second unblocker. And once we identified that as like, we're going to make this exciting for people and we're going to solve the infrastructure deployment problem. That's what really came up with our business thesis of this is how we're going to make a dent in the emissions problem.
I mean, it's an interesting balance between building a company that's kind of purpose native and addressing a solution like climate change, but building a business that's a sustainable business that has profitability. How did you balance that or iterate between those two in the early days, especially as you're coming up with the concepts and the prototypes and the talking to customers? How do you juggle those two things, or align those two forces?
It's really hard. This is obviously one of the major nuts you always have to crack if you're starting a new business, as ambitious as this, especially in climate. I always joke that I wouldn't wish a hardware company on my worst enemy, at least not a hardware startup. It is an incredibly difficult and chaotic thing to do, right? And I think if you're going to do something that is that impossibly hard, you can take on that really hard challenge if you have some incredibly unfair advantage in another area. And I think the unfair advantage that Gradient has is like, we really do have this triple bottom line win. It is much better for the environment. It is much cheaper for the customer. And it is a wildly better user experience. And you don't always find all three wins when you're doing a startup, right? Sometimes you have a better product that's better for the environment, but you have to get customers to pay more for it. Or sometimes there is a view that exists that like people are going to have to accept different and maybe not better, maybe worse ways of doing things to not have an impact on the environment. But that's not true for the sector and for the approach that Gradient is doing. We get this triple win. And because of that, it was almost like once I saw it, I couldn't unsee it as an engineer, right? There was an opportunity here to really make lives better for people who are seeing the effects of climate change today, to make it cheaper for the customer, and to make it way better for the environment. And so I had to do it. I had no choice. I wouldn't be able to sleep if I didn't.
Yeah. You do talk about how one thing engineering school wasn't great for was maybe some of the more businessy side of startup to-dos and tasks. The one that comes to mind immediately, I'm curious how you navigated, is the fundraising pitch. And I know we've got one of your first big VC checks came from Matt Rogers of Nest and now Mill Industries, who we've had on the podcast, who I have a total business crush on. So talk to us about that process of going out to the market to raise money. What was it like to have Matt as your first investor and getting that vote of confidence from such an awesome founder? I think must have been important and interesting and a probably valuable resource in the long haul. So talk to us about that a little bit.
It was. I mean, we would not be here today, or at least we would not be nearly as far as we are along if it wasn't for support from Matt. At the time, investors were not investing in climate or mission-focused companies or hardware or HVAC, right? We had several strikes against us. Yeah. I mean, in 2018, heat pumps were not as big of a talking point or buzzword as they were today. Refrigerants, which are one of the major climate issues, was not even on people's radar. Like I had to define what a refrigerant was. And so when you talk about folks who have that experience, who understand that HVAC can be better and exciting products, who understand that hardware companies are possible to scale, who understand that climate is important and that HVAC is a huge lever, he was an incredibly rarefied group. There probably weren't many other people. And so when we were out telling this story to other investors and they had to educate themselves, not all of them, but many of them had to educate themselves on why HVAC was important, why refrigerants were important, why it was possible to do it. And then when they see Matt Rogers signed on, it becomes obvious, like this is the person you'd want to sign on to something like this. And also Matt, he thinks and talks and works on like 3x speed, as I'm sure you know. And so the conversation with him about what we were doing and how we were going to scale went by incredibly quickly, right? He gets it immediately. Before you finish the sentence, he knows what you're talking about and is already on to your next step. And so he was an excellent collaborative thought partner for early days of the business and introduced us to an amazing industrial designer who is now with Matt at Mill named Rocky Jacob, who helped us make this something that people are excited to have in their homes and that looks great. And that was the next huge step. Once we had the first like professional render of look at what this is going to be in your home, that render told the pitch 10 times faster and better than I ever did.
Yeah.
And so Matt was a huge milestone in the company's progress.
And what about just, the VCs in general? Like, how did you find that process coming from the world of engineering into the world of fundraising? How did you navigate that? What kind of lessons did you learn?
I think that there's a lot of things that you got to change from your engineering days. You've got to stop talking about energy balances and start talking about cash flows, right? There's the entire financial literacy that you've got to learn from the ground up. You have to make it an incredibly emotional pitch. I think that humans make decisions emotionally and then justify them with numbers. I think that this is probably not too controversial aspect of the way humans think and make decisions. And so I really had to shift my pitch. I had been in dozens of conferences presenting technical data where it is an incredibly different type of storytelling. And I had to shift that to like, first, getting people excited about the future that we need to build, right? Getting people emotionally excited about that, having them be able to put themselves in the shoes of the people's lives that we are going to affect, and then work from there down to, okay, now here's how we're going to create the business flywheel that will make this scalable.
Yeah. I'm curious, something that Matt believes very strongly, I think I've heard hints at as you talk about the product, is this notion that, product design is so critical, that you can make hardware that's cool and interesting, even if it is a heat pump, even if it is a thermostat. That actually makes a difference. But also that when you design that product correctly and build it correctly, you can make consumer adoption of a better behavior easier, more accessible, more frictionless. And so I'm curious how you thought about that as you guys went through from that first render through prototyping and building, the idea of facilitating a user experience that's, moves people towards the more decarbonized behavior, if you will.
Yeah, this is, like I mentioned earlier, an incredibly important and emotional piece of people's homes, right? If our product fails in the middle of the night, someone is like waking up from their sleep and having to stress about it. Like, this is an incredibly important piece of people's homes in a negative way, but it also could be in a positive way. I think that solving climate change very much means we need broad buy-in. I think that you can make something that's carbon free, and if no one uses it, doesn't matter. And so the bigger lever on all of the math, if we want to bring this back to math from an engineer's perspective, the biggest lever on the impact we're going to have is going to be the number of people that adopt it, right? Yep. Everyone in the world adopting something that's 10% better is going to have so much bigger impact than something that's 100% better that 1 in 100 people adopt. So we really focused on, let's talk to folks who have problems with their existing HVAC, who are using older infrastructure. There's not a lot of great things about the way we heat and cool our homes with fossil fuels today, or heat our homes with fossil fuels. Cooling is almost always done with electricity. And there's this, I've mentioned this in a couple other talks, but there's this amazing book called Thermal Delight in Architecture, written by an architect from MIT, who makes the point that keeping all of our buildings at 72 degrees everywhere all year round is like an interior designer deciding to paint everything the same shade of blue. The temperature, the airflow, the humidity, the radiant temperature of our buildings is actually a very sensory experience that we spend zero effort trying to control. Sitting in front of a fire at a campsite, or feeling a cool breeze on a hot beach, or walking into a stone church on a hot day and you feel the cold radiate from the walls. These are all really interesting, dynamic, exciting experiences that our thermal sensors are experiencing, but we don't really have the language to talk about them. And so we don't think about them as exciting. And look, we don't have stone church mode on the gradient yet. But what we realized is that it's not just temperature, it is noise, it's humidity level, it's how the airflow moves through the room, it is the natural light coming from your window, it is the fresh air when you can open your window. And if we think about a more holistic view of what makes people's homes exciting and how can we fix it, you get things like the architecture of the gradient that people buy because they get their window back, not because it is a more efficient way to reach a temperature on a hot day.
Right. You mentioned this idea of like the ability to reach mass adoption is a unique lever, a critical lever for moving the needle on kind of the bigger questions around decarbonization. I think that a lot of people historically have this notion of, frankly, I don't think many people have a notion of heat pump technology in general. I think it's like certainly been part of the public policy vernacular the last year or so. But can we start and just have you give folks a little bit of 101 on heat pumps? But then also, I think it's a good opportunity. It'll help us set the stage for you to talk about what's so different and unique about what you guys have built and why yours is just a little bit better, perhaps, we'll say.
How much time do we have? I think the other reason I got really excited about this is the history and the impact of this kind of core technology has been massive, right? It has massively changed the way we work and live in honestly good and bad ways. And it is kind of this fascinating untold story of a really critical piece of technology. You know, we think of like nitrogen fixation and fertilizers as something that changed the world, and transistors and computer chips as something that changed the world. The ability to make something cold absolutely changed the world in massive, massive ways. And like no one tells the story. It is fascinating. There's this menu from sometime in like early 1900s of celebrities and politicians getting together. And the menu said like an apple from Washington and a duck float in from California, right? The idea that you could move food from one place to another via a refrigerated truck totally changed our diets. Refrigerated food added probably a quarter inch to our average heights as a species. And we couldn't build cities like Phoenix without an air conditioner.
Yep.
I live in San Francisco. Before about the 1900s, if you lived in San Francisco, you would never see ice. Actually, I think it's before around 1850. In 1850, they started shipping ice from frozen ponds to places. And so like you would have never seen an ice cube. It doesn't ever get freezing. Like ice is not a thing that you have a daily experience with. And so the technology that makes a heat pump work, that Gradient puts in our systems, the way we need to heat our buildings to solve the climate crisis, is actually the same technology that we use to make your refrigerator cold or make your air conditioner work. It is the ability to move heat in kind of the opposite direction of nature. Uphill, I think, is a good analogy, right? Heat moves from something that's hot into something that's cold. An ice cube melts if you put it on your counter. And a heat pump just moves heat in the other direction. It takes heat out of something that is cold, and it has to reject that heat into somewhere that's hot. It's how your refrigerator works. It's how your air conditioner works. If your air conditioner flips direction, it's taking heat out of the cold outdoors and it's putting it into your room. If you do it this way, you need like 3 to 5 times less electricity. So an air conditioner can be 10 to 20% more efficient if you buy a high-end one. Buying a heat pump over a traditional heater is a third to a fifth of the energy to heat your space. And that's why heat pumps are so important.
Yeah. It's funny. We just, on the introduction to one of our shows a few weeks ago, Glacier Grid, I think, did a real brief history of Frederick McKinley Jones, because I thought it was so, it's like the story that's just not told. It's such a cool story.
Yeah.
Okay, so we've got kind of the backdrop there. But what's so interesting, I think, is how you've thought about it. Like your improvement on it is very tangible, not just making it aesthetically more pleasing, but also like making it easier to adopt, particularly for multi-unit dwellings. I think the micro-split technology is one thing that's part of it. But talk to us a little about like, what your special sauce on top of that then.
So to your point on older multifamily as a sector, this was one of those other things, like I mentioned earlier, that it was almost a win-win in a way that like we couldn't ignore. One, costs of any heating system, fossil fuel or heat pump, are massively high in these older buildings, which also happen to be low income. Because these have old infrastructure, they're also often most susceptible to the effects of climate change. And a core part of Gradient's thesis was from the start, we're investing massive amounts of money to decarbonize our infrastructure. Some of that benefit should go to the people who have the most to lose from climate change. I think that one of the most sticky, hardest to solve issues with climate change, it is very much a problem of externalized costs. The folks who are polluting are very, very separated, both causally in space and in many different ways from the people who are going to see the negative effects of that pollution, right? You're not dumping toxic sludge in your backyard and your neighbor is getting poisoned. We're dumping something in the atmosphere and there are global consequences from people everywhere. And so we really wanted to focus our solution on people who were feeling the effects of climate change today. This sector of older multifamily buildings met that category. And also they have the highest cost for other systems. And also they had some of the worst user experiences in their existing home comfort devices that we could make the experience exciting and better. And so that's why we decided to start here. We wanted to build climate resilience. We wanted to make more exciting products, and we wanted to be cost competitive. And we got to do all three in this sector.
When you think about that and just kind of the way you thought about the market, it seems like you've engineered a product and a new way of looking at the market, which drastically increases the total addressable market possible in ways that maybe traditional folks building in this space hadn't thought of or hadn't planned for. So I'm curious to hear your take on kind of the TAM. And also, I mean, it seems like there is now more public policy support for this kind of technology, these kind of solutions. How has that shifted the business case for you?
Yeah. So we do see our technology as sort of changing the way you would think about the TAM, and I think an important way. And one of the reasons it's important is I remember in my super early days, there was one other HVAC company I knew, and we were part of the same sort of hard tech program. And I was like, the customers in this sector, this is in the middle of my calling all the customers, they don't care. They have no financial incentive to care. There's someone whose job it is to make sure the building meets code for HVAC. They're not paying the energy bills. They're not using the system day to day. They're not even paying maintenance bills, right? And so like, they don't care. How do we get this person to care? And I think that our shift in where the money goes in installing HVAC is important for getting this person to care, because we're taking all of the expense out of the install process and we're moving it into a product that is hopefully in almost all cases way better designed, way more efficient. Eventually, we also want to use this platform to help the building's decision maker understand not just the capital cost implications of their decision, but also the energy cost and maintenance cost implications. So our system is by design, lower cost to operate, lower cost to maintain, higher uptime, both from a customer experience perspective and from a building owner managing the asset perspective. And we need to rethink the way that we have a sale to this customer so that they're realizing at sale the benefits of that energy savings and maintenance savings. And the policy world has helped this because there's now massive amounts of money. Just a week and a half ago, GGRF funds were announced, greenhouse gas reduction funds, which is meant to finance projects that reduce greenhouse gas emissions. And so it is creating a lot of low interest loans to run a project that will reduce emissions. And that type of low interest capital can help us finance a project for a building owner that will pay itself back with energy and maintenance savings. And so it helps us shift from a customer who's saying, I need to update my HVAC system today. It's at end of life. Gradient is the cheapest option. To someone saying, I am going to upgrade to Gradient even though my current system still works because it will save me money today because this project is going to be lower cost over the full lifetime. And so we're going into a sector where a very simplistic view would have been, all right, this building spends a couple $100 every 5 years on a window AC. Like that is a small TAM, but it's not a small TAM because you're not counting the energy cost, the like human suffering cost, the cost of the heating system that you're not replacing into that. And so, that's a long way of saying we think of our product as not just a piece of hardware. It is heating, cooling. It is an energy asset that the building owner has to manage, and it is lower maintenance. It is more a broader part of a building electrification strategy.
So there's another interesting piece that I want to get into that comes along with Gradient's being a hard tech startup, and that's the actual manufacturing. It feels like it's pretty common at this point to talk about how companies are thinking about the infrastructure for clean energy and how policy can enable that. But I do think that we're not talking quite enough about another aspect, which is workforce development. And so I'm curious how you're thinking about workforce development when it comes to manufacturing and just building the actual products these days.
Sure. So broadly, the way Gradient thinks about workforce, we've got to decarbonize is one of our main goals. Helping people who are susceptible to the effects of climate change is tied for first. And I think third is we should think about workforce as we're spending, especially federal dollars to electrify. Who is getting the economic benefit of that investment? Who's getting the jobs from that investment? This is important for us as a country because, frankly, I think a lot of the political conflict around climate change is because we're often moving money and jobs from fossil fuel producing states to states that are economically doing better anyway. And so I think we need to think about decarbonization with the lens of how are we going to make this economically better for all Americans in terms of jobs, in terms of income, in terms of quality of life. And so, especially if federal dollars are going into the sector, this should be creating as many American jobs as possible. We focus on how we can more quickly train people to become HVAC installers. This is a huge piece of this. We focus on how we can more quickly train people to maintain and support HVAC systems. Our system is way easier to support. So we believe we can train people faster and they can do more work. And then lastly, we also think the manufacturing side, who's getting those jobs, is really important. It's also worth pointing out that many folks who are going to suffer the effects of climate change, those effects either could be fixed by or are directly related to money, right? It is people who are losing their livelihoods because changing weather patterns changes the way they run their business, or people who have an unexpected expense because of a flood or a heat wave or something. And so economic opportunity is a huge part of how I think our country needs to think about decarbonizing.
Yeah. I mean, we use the word sustainability in a very inclusive, broad sense to try to intentionally allow space for all of that to be part of the conversation. What are you most excited about? I mean, you guys seem like you're on this incredible trajectory. What has you most excited coming up in the future?
I think that there's always, especially when you think around climate, reasons for optimism and reasons for pessimism. I've spent many years fighting against the will of the American public to understand this massive problem that we're working on. And at times it seems slow and then it kind of happens all at once, right? We were selected for Clean Heat for All, which is our large contract with New York Housing Authority, the same week that the IRA passed. At that point, I had thought Build Back Better was dead several times. And all of a sudden, in a month, the world changed. Everyone was talking about heat pumps. I think the thing that I'm most excited about for Gradient is seeing the reaction from our early customers, especially in NYCHA, New York Public Housing buildings. There was recently a local news story where they interviewed the residents, and the residents were talking about how it changed their daily lives, how they're more comfortable, they can sleep better, they can breathe better. And I didn't really see it coming. I didn't know that this local news story was interviewing them. And I watched it, and you see these people who are living and sleeping with our system. The first day we installed the new generation of systems, I was refreshing the status page to make sure everything was going well. And hearing from them that it changed the way that they live was really important. It's kind of why we're here. And it's just a couple people, but I think ultimately focusing on the little progress we can make to both, do good for the planet and do good for people's lives is what gives me optimism.
Yeah, I mean, it's only a few stories, but it's a few stories that make it all worthwhile, I think.
Yeah.
And it's indicative of something broader.
It goes back to this whole journey of making the story personal at first, right? When we tell a story of why Gradient needs to do what it needs to do, it needs to start with our personal daily lived experiences, both on the negative side, how is climate change changing the lives of these folks who a hurricane hitting New York is flooding basements, they don't have heating, and they're having to live through New York winter with no heating. To how this investment in our infrastructure has made their day-to-day lives better. I think that telling these stories is what's really important about educating the broader public about the effects of climate change.
Yeah. And it feels like holistically, again, once you have that triple bottom line value proposition that will make things cheaper, better, more efficient for any consumer, any American who purchases it, any homeowner or building owner who installs it, you're on the right path, right? Because then everything's on your side to move things in the right direction. It's about building a better product and building it at a more cost-efficient price point.
It feels like there's this general attitude that in order to solve climate change, we have to make our lives worse. And if you step back and you think about it, what we're mostly doing is changing 100-year-old infrastructure, right? There is no way that we can't do things better than we initially designed them to be literally 100 years ago. I think it is one of the exciting parts about entrepreneurship in the climate world right now is that we do have the ability and now the resources and political will to change over a 100-year-old infrastructure. And we get almost a blank sheet of paper to say all right, this is a once in a lifetime opportunity. How are we going to make this better for the next 4 generations?
And move the needle. Maybe not move it all the way, but move it 3/4 of the way and then be in a better position a decade from now to continue working that last quarter as far down to zero as we need to possibly get.
Exactly.
You're certainly operating at the tip of the spear in climate tech and with your engineering prowess and perspective. I'm curious what next big innovations you're seeing or fields of research in climate tech or sustainability you're kind of keeping your eye on. Maybe some that maybe affect your work, but others that just in general that you're seeing. What are the next big breakthroughs that you're hearing about or seeing or reading that you think other folks would find interesting?
I was at this great talk by Tom Steyer, where he made what now seems like an obvious point that in the early 90s, you would say that you were working for an internet company, right? The internet was a new thing. And so you'd be like, my company does something with the internet. You wouldn't say that today. The internet is so deeply embedded into everything about how we live that it is the waters that we swim in. And I think that is becoming true for climate. I think that almost everything that we do, especially from a business standpoint, has some effect on the climate. If it's not emissions, it is how we as people in our daily lives respond to climate. And with that broadening definition, we see climate efforts show up in different ways, right? We see it around farming, around local ecologies, around food waste, to use mill as an example. And I think the exciting part is this more holistic view on climate. It is causing us to think about the sort of adaptation effects of climate change and how we can fix them. It is causing us to think about jobs and economic opportunity. And it is leading to all of this like exciting wave of climate companies that isn't just about cars and electricity generation. It's about how we eat. It's about how we live. And so all of the work, I think, in food, both production and waste, is really interesting to me. I think all of the work that is very community-based is particularly interesting to me. I think there's a lot more community-focused climate efforts. We're part of Elemental Accelerator, who is a very sort of public health first, community engagement focused climate group. There's a company there that is working with a invasive species of deer in both controlling the population of deer and creating sustainable meat from the deer as a protein source. And so I think this more holistic, connected, people-focused view of climate is what's most exciting to me.
It also makes me wonder if that perspective, which feels broader and more inclusive of other parts of the economy, other parts of business, also is an invitation to more people to become engaged, right? Like
Exactly.
It'll touch more sectors. Everyone will have someone they know who's working in the internet, well, now working in climate tech, clean tech, in ways that I think hopefully will encourage us all to kind of adopt or understand and appreciate, hopefully adopt a perspective that leads towards solutions.
We're finally wrenching the climate story from the hands of the scientists and engineers, whom I love because I am one. And it is now becoming a story of the communities and the community leaders and the people in their homes, as it should be. I think climate change wouldn't have been as controversial if we started off not talking about the polar bears, but talking about the people, about the public health challenges associated with it. And I think we are getting there today.
I want to end on hopefully a bit of an inspirational question, which is, if you think back at the end of all you've accomplished to what your legacy will look like, what do you hope that legacy is?
It's a good question. I've never been, despite now being on the podcast circuit, someone who was looking for the spotlight. I hope that Gradient's legacy is less about me and more about the people's lives who've changed, right? Like I really want the spotlight to be that resident who had trouble controlling their heat in the winter, who couldn't breathe because it was always hot and stuffy in the winter, who couldn't sleep because their window AC was loud. And now the way they've lived their lives has changed. And as a benefit, we've also decarbonized, right? That is what I want to be the spotlight. That's what I want to be the legacy, is this idea of climate change ultimately being about people, ultimately being about communities. And that if you think solving climate change means our lives are going to be worse, then you are probably just being wildly uncreative of what our infrastructure could look like. Yeah, I hope that's it. I hope that my legacy is just one of people-focused engineering.
I like that. Huge thanks to Vitz for joining us on the show today. I love the work he's doing to make HVACs not just cleaner, more efficient, and even more beautiful, but also his commitment to making sure they're accessible. I think what he said there at the end is really so true and stuck with me a lot since the interview, that solving our climate challenges is ultimately about making people's lives better. When we bring our creativity and our hard work to designing solutions that improve our quality of life by reducing our footprint, that's how we get where we want to go. Also, the Gradient systems just look really, really cool, and I would have killed for one back in my New York apartment days. Anyway, you can find out more about Gradient at gradientcomfort.com or connect with them on Instagram and X at gradientcomfort. We'll have all the links for you in the show notes, so go check them out. As always, you can reach out to us by email at cic@consensus-digital.com. That's cic@consensus-digital.com. or you can connect with me directly on LinkedIn and Threads at ckgaughan. That's at CKGONE. Would love for you to reach out with any questions, comments, or ideas sparked by today's chat, or if you have a great suggestion for a future guest. We'd love to hear your thoughts and get your feedback. It's always fun to connect with folks who share our passion for these topics and helps us make a better show. Finally, if you did enjoy the show today, the best way you can support us is to give us a follow and leave a review wherever you listen. That helps us grow our reach and continue bringing you more awesome conversations with business leaders you want to hear from. Thanks, everyone. We're back next week with a brand new conversation. Consensus in Conversation is hosted and executive produced by me, Conor Gaughan. The episode was produced by Will Gatchell and Jeff Rock with editing from the good folks at Reasonable Volume. Special thanks to the Consensus team, including creative director Kate Tucker, Greg Hergel on research, and Patrick Gallagher on strategy. Consensus in Conversation can be found on Apple Podcasts, Spotify, YouTube, or wherever you listen. Consensus in Conversation is a podcast by Consensus Digital Media, produced in association with Reasonable Volume.